We continue on our journey of equations. Today, the next thing we're going to look at is graphing an equation. So a graph of an equation is all the points in a plane that the coordinates x, y satisfy the equation. So, for example, we started with the equation y equals there. So if I had the points, and I'll make this my x's and this my y's, and I had like -2, -1, 0, 1, 2. And so -2 squared is +4, -1 squared is 1, 0 squared is 0, 1 squared is 1, and 2 squared is 4. So when I graph by plotting points, I make an XY or an input-output table, and I kind of have to have an idea of the inputs I want to look at to have meaningful y values. That's one of the hardest things about an input-output table. When someone tells you plot these points and it gives you what x values they want, that's much easier. But when it's open-ended, it can be kind of tricky. The next one would be 9. So I'm just going to put a little arrow saying that's continuing that way. Lovely, right? So if I wanted the equation x squared plus y squared is equal to 10, now that's a harder question. It's harder to say input and output. But take a minute and think of some coordinate points that must be true for that equation. To come up with a couple, pause the video, it's okay. Alright. So there's lots of different possibilities. I particularly like 1 for the x. So that if x is 1, you'd have 1 squared plus y squared is 10. And y squared is 9. So then y is positive or negative 3. So 1 comma 3, and I'm also going to list 1 comma negative 3. Similarly, if x is 3, then y would be 1, or y would be negative 1. And then maybe we'll say, what happens when x is 0? Well, it would be square root of 10 or negative square root of 10. Here, I'll put that as well. So I'm going to plot some of these so far. So square root of 10 is going to be a smidge past 3. I've got 1 comma 3, 1 comma negative 3, 3 comma 1. You might even add square root of 10 comma 0. And negative square root of 10 comma 0. And we'll see what's happening here. You end up with a circle. You might recognize that equation from geometry as the equation of a circle, but you might not. It's okay either way. So that was graphing by plotting points. And that one was a little trickier. Oh, go over here. Next, we're going to graph with the graphing calculator. So here I have my graphing calculator. When I want to graph with the graphing calculator, I'm going to start by pressing y equals. It's over here on the left. And if you see second, it's right above that, y equals. Clear out anything that's in there already. And let's start with that same first one of y equals x squared. So I'm going to type in x. Now you can do x two different ways. I like the x that's right next to the alpha button, but you can actually hit alpha and then the stow button down here as well as another way to get to x. So I'm going to hit x and then I'm going to hit squared. Okay, so that's what that looks like. And then I'm going to hit graph. You can see the lovely graph that comes out. So And I get the same kind of shape I got on my biplotting points. Couple of cool things. I can hit trace and it follows along where the curve is. I can also do second trace. That gives me the calculate menu. And then if I wanted to plug in a value, like let's say, what's the value when x is 3? And it'll tell you. And although I can't see it on mine because I don't have it, let's fix my window for a minute. Zoom 6. Try again. Second trace. That first one value when x is 3, y is 9. And it plots it for me. And it shows me it down here at the bottom too. So you can see right here. Oops. Sorry about that. It's right here. Very cool. But there's a problem. When I go to graph x squared plus y squared equals 10, it's not solved as y equals. So TI graphing calculator in 83 or 84 or any of those versions work best for what's called explicit equations, equations that are solved for y equals already. Something like x squared plus y squared equals 10 is much harder to graph because I'd have to first solve for y. Okay, go ahead and try and solve for y and see if you get the same graph as what we got before. It's much harder, isn't it? And I bet some of you accidentally got 2 lines when we shouldn't have that. So, for a harder equation, or this implicit curve, I think Desmos is a better tool. We'll show you how to get it for our calculator. We would have to have y squared is equal to 10 minus x squared. Y is equal to the square root of 10 minus x squared. You'd have to have a plus or minus in front of there. And you do not want to simplify this because you cannot simplify radicals over subtraction. So, yikes. Okay. So, different type of equation, different tool is needed. What we're going to use is Desmos. Okay, so you're going to head to desmos.com. So over on this left-hand side, I have my equation where I'm going to type that. So I'm going to type in, first let's do the y equals x squared that we had before. Boop, and let's see, my graph just goes right there. Oh, fantastic. Okay, very, very cool. You can trace along it just like you can with the other one. And you can even, if you're going to be really fancy for a moment, you can turn it into a table of values and get what that same input-output table we had at the beginning. Very fancy. What's cool about Desmos, and I'm going to turn this one off because I don't want it anymore, is it can actually do the implicit curves as well. So even though our calculator struggled with x squared plus y squared, I can do this in Desmos no problem. For squareds, I'm doing shift and then 6 to get the caret key, but alternatively you can also hit this little keyboard down here at the bottom and hit squared here, or even A to the B and then type in a power of 2, or if you were looking for a higher power. And so then we had it was equal to 10. Oh, look, there's a lovely circle. Again, you can trace along it. It gives you the decimal approximation for any radicals, but that's pretty good still. And even here you can see, oh, there's the 3,1. I knew if I hovered I'd be able to get to it eventually, and 1,3. Okay, very cool, very fast, very efficient. Okie dokie. So, Desmos, super cool. I would actually bookmark it on your computer right now because we're going to use it obviously a lot. So an intercept is any point at which the graph crosses or touches a coordinate axis. And so an x-intercept is where we cross or touch the x-axis. And a y-intercept is where we cross or touch the y-axis. What's cool, if we want to find them in Desmos, ready? Let's go back to Desmos for a second. I can literally just boop, 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 and to boop on the last one. And it gives them to you. And that's true about any equation. So let's say 3x squared minus 5x plus 1. Yep, plus 1. There we go. Goodness gracious. There we go. Plus 1. Okay, if I had two x-intercepts, and I can just tap right on them and it gives me the x-intercepts. Similarly, I can tap on it to find the y-intercept as well. Okay. Calculator's a little bit trickier. Okay. Let's take that same crazy one that I just wrote. Let's see. 3. Oops, that's a 6. 3x squared minus 5x plus 1. So I hit graph. If I want to find the x-intercepts, I'm going to first zoom in a little bit so I can see it a bit better. So watch, I'm just going to zoom in right over here. Ah, so much better. So second, trace, it opens this calculate menu. Okay, I'll just show it just a little bit. So if I want to find the x-intercepts, we're going to look for what's called the zeros. Okay. Now, the zeros, it asks you for what's called a left bound first. When I want a left bound, I want to be left of the 0. See how I have a 0 right there, or an x-intercept right there? I want a left bound, and then we're going to shimmy above it to get a right bound, because now my x-coordinate is right of it. And then one more time for good luck. Boop. So 1.434, and what did I get here? 1.434. Okay. I can repeat the steps to find the other one. Second trace, 0. Then I'm going to left, to the left, to the left. Every single cursor is going to go to the left. And then a little bit to the right of it, which happens to be below in this case. One more time for good luck. 0.232. 0.232. Again, Desmos is much faster, but it's important to know both skills. Okay. Oh. All right, so take a minute and find the x-intercepts and y-intercepts of the problems on page 6. And we actually did this one already, so check, that one's done.